Hey everyone, this is Snake here, and as promised, in today's video, we are going to continue on with binary arithmetic, the multiplication and division part. So, let's get started. So, guys, to understand multiplication, let's start off by multiplying two numbers. Let's take two numbers, say 27 and 23. Now, let's multiply them, okay? So, first 7 times 21 and then 6 times 8, this is 81, and then 2 times 7, that's 14, 1 goes 4 5 53, 54, and then we add up those numbers. This would be 1 2, carry of 1, and that's 621. Okay, now in this process that we were taught today, we have to understand what is actually happening. Why the question is that why is this shifted to the left by one place? Okay, let's get expanding. Okay, so the multiplication can be written down in the form of 2 times 10 plus 7 times 1. This is the 27 one, and then we multiply that with 23. 2 times 10 plus 3 times 1. Okay, so now let's split them. 2 times 10 plus 7 times 1, that would be multiplied with 2 times 10 plus 2 times 10 plus 7 times 1 times 3 times 1. You see, already from the get-go on this step, you can see why this gets shifted here. It's because of this 10 that we're multiplying. It modifies the weight of the of the digits basically. So you see, in the next step, we will get basically, if we multiply the 2's and 10's, this would be 4 times 100 plus 14 times 10. Okay, let's leave it at that for now. And then on this side, it would simply be 6 times 10 plus 21 times 1. Okay, now this 14 here and this 21 here can be expanded further. Okay, so let's do that. So this would be 4 times 100, and this here, this would be 10 plus 4, and that 10 gets multiplied, so that would be 1 times 100 plus 4 times 10. Okay, and then on this side it would simply be 6 times 10 plus, this is 21 here, so this would be 20 plus a 1, so that would be 2 times 10 plus 1 times 1. Okay, that's how the split occurs. So let's get arranging this here and this here. This would then become 4 plus 1, 5 times 100. Okay, then this would be 4 times 10. Then here this would basically be 6 plus 2 8, so 8 times 10 plus 1 times 1. Okay, then finally we can write this down as 5 times 100 plus 12, 4 plus 8, 12 times 10 plus 1 times 1. Okay, so again this 12 can be split further, can be expanded further, so that would give me 5 times 100 plus 1 times 100 plus 2 times 10 plus 1 times 1, and this 5 plus 1 would become 6 times 100 plus 2 times 10 plus 1 times 1, which finally gives me 621. So now you see, this is how the multiplication process that we were taught as a child basically. This shift here occurs because of this 10 here, you see. So the case to consider in multiplication is in the scenario when you are given fractional numbers or decimal numbers basically. numbers with points. Okay, let's take this example only, this 27 times 23, and let's say you were given 2.7 times 2.3. What do we do in this scenario? Well, basically, as a child, you were taught that you take the number of decimal places, say this is 1 and this is 1. So there are two places. So you shift 2 points in the answer, the product basically. So it becomes 6.21. Now, what is actually happening here? Okay. See that you will notice that I can write 2.7 as 27 times 10 to the power minus 1. Okay, this is same, basically it is 2.7 only. And similarly for 2.3, I can write this down as 23 times 10 to the power minus 1. Now if we are multiplying this, then it simply is like 27 times 23, and the whole is multiplied with 10 to the power minus 2. So in this above solution that I have shown you in expansion form, it is simply multiplying the entire thing by 10 to the power minus 2. Okay, so that means in every step we can just perform the multiplication as if we are multiplying two integers basically, and at the end when we finally reach the product, we simply multiply the accumulated 10 to the power values, and we'll get the answer basically. See, that is what actually happens, and that is what we are actually taught in childhood. This was like magic to us, that oh okay, we will just memorize it, that if there are the number of decimal point places that we just have to place the decimal point accordingly. But no, what is actually happening is we are turning them into integers value and combining the 10 to the power values, and then finally multiplying it with the product of the integers we have multiplied. Okay. Okay guys, moving to binary multiplication, I want to think of two different observations. Okay, in the first scenario, hmm, let's take a situation where you multiply a number with 0 and when you multiply a number with 1. What happens in these two cases? Okay, in the first case, you see the output will always be 0, and in the second case, the output will always be the number itself. Okay, now in a second case, in a second scenario, the point to consider is how many symbols or how many digits are there in the binary number system. There are only 0 and 1. Isn't that right? That's what makes it binary. So try to guess ahead. What is this? Okay, it basically means that when you are performing binary multiplication, when you're considering digit by digit, it will always be either 0, or when you multiply it with 1, it will give the number itself. Okay, let's see it in action. Okay, so let's take a binary number, say 1101. This is basically 13, and say another 101, which is basically 5. Okay, and we are going to multiply this. So you see, remember these two cases here that I written down. What happens when you multiply this binary number with 1? It will always give the same number, 1101. Okay, and then just like normal multiplication, you shift it to the left, and now you're multiplying the entire number with 0. So the entire row will become 0. Then you shift it twice, and then you're again multiplying with 1. So that means it would just be the number itself. And now finally you add them up. So this would become 1, this would become 0. Remember the rules of addition that I taught you in the previous video. Okay, 1 plus 1, that would be 0 here, carry a 1. 1 plus 1, 0 here, carry a 1. 1 plus 1, 0 here, carry a 1, and this would finally be 10 here. Okay, this is the answer. This is basically the number 65 actually. Okay, so see, understand this magic here that happened. This is the reason why binary multiplication is so easy. Okay, in normal decimal multiplication you had to multiply it by a factor of 2, 3, up to 9, basically whatever number, whatever digit you are multiplying with. But in binary it is just 0 and 1. It is either the entire row becomes 0 or the entire row becomes the number itself that you're multiplying with. That's what makes binary multiplication so easy. Okay guys, so guys, are you ready for a boss fight? Let's get started with division. Okay, so first let's see the process of division. I'm going to take easy numbers. Okay, let's take 231 and let's divide this by 10. Okay, so first we multiply 10 with 2, that gives us 20. So there is a remainder of 3, we bring down the 1, that's 31. We multiply 10 with 3, that gives us 30 and leaves a remainder of 1. Now you see the final remainder is less than the divisor, so we stop here. Okay, this is the chain method or the long division method. Okay, now there are very key things to observe here. Okay, in the process that we have been doing, you see that we recursively or we chain division one step after the other. We divide here first with the main number, then we divide the remainder again. Okay, and another thing to notice is that we assign the quotient, the quotient here in the weighted form already from the very beginning. So let's see this process but divide it up into steps. Okay, first let's divide 231 as we did before. That would give us 20, but this time I will not bring down the 1. Okay, I will multiply this with 20, so this becomes 200. After all, 10 times 20 is 200, and this then leaves a remainder of 31. Then separately we divide 31 with 10, and that would give us 30 and would finally leave a remainder of 1. But now since 10 is 1 is less than 10, we cannot continue the division further. Okay, so to understand this, let's write down this algebraically. Okay, so the main number is dq0 plus r0, and then see we take the 31 and again repeat the division. We divide r0 into the form of dq1 plus r1. Okay, now let's back substitute this. So the finally d becomes dq0 plus dq1 plus r1. Okay, and we can take the d's common here, so this becomes dq0 plus q1 plus r1. So r1 is the final remainder that leaves behind, and q0 plus q1 is basically 20 plus 3, that is 23, which you saw in the original division that we had performed. So you see, the long division is basically a series of division where you divide once and you assign the weights to it. That is why you see I wrote this down as 2 times 2 into I wrote this down as 20 basically, and each successive step it gets reduced by one weighted digit value basically, and finally that q1 plus q0 plus q1 gives me 23. So now let's take the scenario when the remainder is less than the divisor. Okay, let's take an example, say 2, and we divide that by 7. Now what was the process that we were taught as children? Okay, since it is already less than 7, we put a 0 on top and then a decimal point. So now we can take a 0 here. So 7 times 2 would give us 14. That would leave a remainder of 6. Then we turn it into 60. Then 7 times 8, that would give us 56 and leave a remainder of 4. Okay, now let's observe this process. Let's study it. How does these zeros magically appear and that we can take as many as we want? Now that's a very important question. Okay, but you will see that the logic here is very much similar to the one that I showed you during the case of multiplication. Okay, see, 2, I can write this down as 20 times 10 to the power minus 1. Okay, I could even write this down as 200 times 10 to the power minus 2, and so on. So you see, this is basically the reason why I can take as many zeros as I want after the decimal point is placed on the quotient. Because you see, let's take this scenario. Okay, we are since we are turning 2 into a larger integer that is greater than 7, basically we keep a record of the 10 to the power values that we are doing here. Okay, so for this scenario, let's turn it into 10 to the power, and we turn 2 into 200. Okay, and we simply perform integer division here with 7. So here it would simply be 2, that would give us 14, leave a remainder of 6, bring down the 0 here, 7 goes 8, that would give me 56, and leave a remainder of 4. You see what we did here? It is just plain basic integer division that we shown you in the earlier part, but we are keeping a record that we have to finally multiply 10 to the power minus 2 with everything, both the quotient and the remainder. Okay, see what happens. Remember that d is in the form of dq plus r. Since we are changing the form of d, that it is 10 to the power minus 2, so dq plus r, this section will also be multiplied with 10 to the power minus 2. That means q will be multiplied by 10 to the power minus 2, and so will the remainder as well. Okay, if you don't believe me, see it for yourself. Okay, so multiplying this would give me 0.28, and the remainder is basically 0.04. So 7 times 0.28 plus 0.04. So let's multiply this. 28 times 7, 7 into 8, 56, 7 to 14, 14, 5, 19. Okay, 1.96 plus 0.04, and that gives me an answer of 2. See, we got back to the same point. This is what happens under the hood when we do a division where the dividend is less than the divisor, basically. How the logic of the decimal point actually works behind the scene. It is the same as the multiplication process. We are just keeping a record of how many 10 to the power 2 we are taking, 10 to the power values we are taking, and we increase the number to any values that we want to the how can I say this, decimal precision that we want, basically. In our case, we took up to 2 to the power 10 to the power 2, so we turn the number into 200, basically. If someone tells you up to a precision of 6 decimal digits, you turn that into 10 to the power minus 6, basically. That's how the process is done, actually. So no need to memorize, just understand this. Okay, so guys, the boss fight out of the way, let's move to binary division. Okay, and again I would like to restate that in binary we have to work with only 2 digits, basically 0 and 1. Okay, and also remember that whenever we multiply with something with 0, it gives us 0, and when we multiply a number with 1, it gives us the same number itself. Okay, now let's get dividing. Let's take a number, say 11001. Okay, and let's divide this with, say, 101. Okay, so the thing we can do here is, unlike the decimal scenario where we have to worry about factors, we no longer have to worry about factors. Here we can multiply this divisor with either 0 or 1, nothing else, basically. So let's take the 3 digits here, and we multiply this divisor with 1, so it gives us that very same number, 101. So we perform the subtraction here. This would be 10, this would become 0, so 2 minus 1 1, and the 0 minus 0 1, so the rest will be 0 here, and we bring down this 0. Now this is still less than the divisor, so we take a 0 on top and we bring down the 1 here. And what do you know, it's the same number though. So let's multiply the divisor, 101, and thus it leaves behind no remainder. And this is how binary division is done. You see, that's all it is. You just have to worry about two scenarios, multiplying it with 0 and multiplying with 1. That is why binary multiplication and division is itself easy, but the understanding of the division and multiplication process is the hardest part basically. So guys, with this I end my video today. Please put all your queries in the comment section and like and subscribe to my channel. And remember, to learn, never memorize. Bye bye.